Hello and welcome. Thanks for coming back from that 10-minute break. But there's a big break afterwards. So if you can stick around, that would be fantastic. I'm Andrew Scheps. I'm a record producer, mixer. Basically, I make records. I've been doing that for a really long time, which is a little scary when I do the math. But yeah, almost 40 years now because I'm kind of old. The genesis of this talk is from a conversation I had with Bobby Lombardi when we were taking a train up to Birmingham. And the thing I want to say about that first is he had stayed at our house after we went down to check out the venue in Bristol where ADC is going to be uh, in just over a week. And I had gone down to meet him because I wanted to introduce him to a cake shop called Ah Toots, which you can see in Gathertown. But it was a Tuesday and they were closed. And it's one of the most disappointing days of my entire life, going all the way to Bristol to find out that I wasn't going to get cake. So if you're coming to ADC in person, I would highly recommend you get over to Ah Toots. But keep in mind, they're not open on Tuesdays. I think it's Thursday through Sunday, something like that. Anyway, we were on a train and we were just talking about interfaces, and there's a particular reason it came up, which I'll get to sort of at the end. And it's easy to sort of put together a title before you've done the talk, and then you realize that you put AI in the title of the talk, and then you realize, well, but I don't really want to talk about that too much. That is where we're going to end up, is sort of the AI tools that are available for making records right now and their interfaces, because it runs the gamut of very high level interfaces to unbelievably tweaky interfaces. And I think that that really all comes down to application and how the user is using it. So I'm not going to be really talking about using AI to create tools, because that's what you guys do and you know a lot more about it than me. But I'm going to talk about eventually how that has impacted making records. But I want to start just with UI. I want to talk about UI for a bit because I just find this stuff fascinating. Whenever I talk about anything, I end up diving into the history a little bit. And really quickly, one book that I found that is fantastic is called Push Turn Move. And it's interface design in electronic music. And it's about all the classic drum machines and synths and moving on to modular synths. And it's a really fantastic book by Kim Bjorn with a forward by Jean-Michel Jarre. So if you're into electronic or ambient music from way back, you're certainly aware of Jean-Michel. And what it's got very close to the beginning of the book is this sort of idea about how to think about the interface you're building. And I found this really interesting and obvious. And whenever you see something that's right, it looks obvious, even if you've never seen it before. So basically, you've got three different areas you want to think of. So the first is the user. I mean, and if you're designing a UI for a user and you're not putting them first, well, then that's just an oversight. But the things that are important are, what is the skill set of the user you're targeting? Do they know what goes on inside of your product? Or do you just want them to have a vague idea of what it is they want to do and give them just enough controls to get through what they want to do without having to know what's going on under the hood? And they're really good examples of both styles of newer AI products. Another one is, what is the purpose of it? And I think this goes as much to the design of the product itself as it does to the UI, but it's obviously to do with what situation is it going to be used in. And there are a lot of UIs we'll see in a second to do with performance, where you need to be able to get around those very quickly and recognize things from far away at just a glance, rather than having lots and lots of buttons that sort of look similar because they could do different things. And there's some really good examples of that. And that also starts to bleed over into context, which is the environment it's going to be used in. And then also other considerations, like if you're building a hardware box, well, what are you going to make it out of? What's the supply chain like? How durable is it going to be? And if it's software, like how much screen real estate do you need? You're going to have multiple pages and things like that. So there's a lot that goes into this. And I'm sure you all think about this and actually know more about it than me, but I like the sort of high level thinking. So historically, let's just talk about music gear, because that's what I do and it's what a lot of you are into. Let's go back to the Wayback Machine of analog hardware. And in analog hardware, the UI was basically direct control of circuit elements, right? Every knob on that NEVQ at the bottom is controlling a resistor, basically. It just switches resistor values in a circuit. Fairchild, same way. LA2A, same way. The Studer A800 that's the tape machine on the top left, is a kind of interesting bridge between the pure analog, I'm turning a potentiometer that changes the resistance in a circuit, into some of the sort of earliest of the digital interfaces for analog hardware. And I'll get to that in a second because that is the downfall of an entire decade of my life, is navigating these very small boxes that have a million functions and you can't get to them easily. So the poster child for this is something called the timeline links. So this was a synchronizer. It has a big multi-pin connector on the back, and you would have a different cable for whatever tape machine you had. And this synchronizer would get information about your position from time code and how fast the tape machine was running. And then you would hook up multiple units, and that would lock up the tape machines so that they would run in sync in some reproducible way, which is good because if you're recording to a second tape machine, you want to be able to have that stuff stay in sync with the first tape machine every single time you do it. So this is really the innovation that allowed the multi-track tape recording that had been developed from sort of pre-Beatles, where you started off in mono, then you went to 3-track recording, but still monitoring in mono, then to stereo, and eventually sort of 24-track tape, a 2-inch tape with 24 tracks on it, became the industry standard, with some people saying 16 tracks sounds better and blah, blah, blah. But as soon as you wanted to go over 24 tracks, you had to start using more than one tape machine. Obviously, digital DAWs, recording to computers, didn't even really exist at that point. So you'd be locking up multiple tape machines. And as soon as you do that, you've got analog tape machines, which when you hit play, they sort of kind of run at the speed they're supposed to run at. But it's a phase lock loop. So they go a little fast, they go a little slow, and they're constantly slewing their speed around. And so then you would print a square wave onto a track of tape, and that square wave would be encoding time code. The links would read it, the links would have control over the transport, and you would say, I have 2 tape machines, and I want one of them to be the one that I hit play on, and that will be the speed that everything else needs to go at, and it would locate and control the speed of lots of other machines. It's a really complicated device, and I don't know if you can tell by the picture, but it's a half rack space. It's 1 rack space high, and it's only a half rack width. And there are a million options. So really quickly, kind of slowly, this is the installation and simplified operation manual, and this is the first 3 pages of about 70. And this basically, I'm going to glance over the presentation itself just because it's a little bit small for me on my presenter screen. It tells you how to set up the display. It tells you, you don't even get to the point, I think, where you can choose a tape machine. But choosing a tape machine on this box was an absolute nightmare. I mean, if I go back to the display, there is basically what you've got is you've got 8 segment displays. And so it would be spelling out words like Studer and A800. And so you'd have to find a manufacturer, and some letters really don't show up well on that kind of display. And then you would hit go and you'd get into the submenu. And so if you looked at a menu tree of controlling this device, it was an absolute nightmare. But the idea was that you would only do this in a setup mode, and then you would have a very intuitive interface, which is more like what we were talking about before, where you could very quickly glance, look at the lights, know that tape machines were actually in sync, and you had buttons to take things on and offline and simplify in that way. So actually running the software was an absolute nightmare, but you didn't have to do it that often. I want to go back to the A800 tape machine. This is one of the best sounding tape machines ever built. One of the things it could do is to vary speed. And you can see on the right, they've strangely the manual, the left side of the page is in German and the right side is in English. And on the left side, it says very speed, which is what everybody I've ever met in the universe calls very speed. But they have translated very speed to vario speed because you vario it or something. So this is a recording technique that unfortunately is a bit lost in present day digital recording. You can do a version of it in Logic pretty well. I would imagine you can in some other DAWs where you can basically just completely change the speed of the transport while recording. And then when you play back at your original speed, the pitch of that recording shifts along with the track. So the track goes back to your original tuning, but your new recording is pitched up or down compared to what it was when you recorded it. It was fantastic for when a vocalist couldn't quite hit that top note. You would slow down the track a half step. They would sing the top note. You'd speed it back up. The formant wouldn't have changed that much, and you'd get away with it. You could also slow it down to play a very difficult passage on guitar and then speed it back up. Recording percussion. It was great to record it a little bit too fast because when you slowed it down, it would naturally take care of some of the harsh high end that you would get off of a tambourine or a shaker. Huge part of analog recording workflow. I would imagine if I was in a tracking date, I would vary speed at least 2 or 3 times a day and sometimes all day, changing speeds. And an example of this would be on the Chili Peppers record Stadium Arcadium. If you listen to a lot of the guitar overdubs that John Frusciante did, they're very weird guitar tones, very glassy, some of them. And that's because a ton of those were recorded with the tape machine sped up or slowed down. Okay, this brings me to why this is such an absolute nightmare. You may have read the text on the right while I've been blabbing on and on about why we used it. So let's say that you wanted to slow the tape down a third. Okay, so you need to slow the tape down 4 semitones. Have I done that right? I've done that right. So if you look at the way you would set the Studer, it says that you're going to be shown a number. If you look at your the calculation there, Z is the number displayed, and V is the percentage you want to slow the tape down. Now, the problem is you're dealing with a logarithmic scale with pitch, and you've got a linear scale of speed. So this is only half of the battle, but you don't even set the value for the percentage you want to speed up or slow down the tape machine. You have to set some crazy number that, when divided by 32,768 and taken away from 1 and then divided into 1 times 100%, gives you the percentage you want. Absolute nightmare. But this still doesn't even get you to pitch. So we'll just have a quick look at what gets you to pitch. So you start off with this, right? Now, this means that the number I actually am worried about hasn't been solved for. I need to know the number that I want the tape machine to look at. So first we need to switch this around. I had ChatGPT do the math, and I had to put these in using latex, which I'd never used until I made this slide. So if the formula is wrong, it's a concept. It's not a formula. But let's say that that's right. So now I've got a way to calculate the number I have to set the tape machine at if I know the percentage I want to speed up or slow down the tape machine. But that doesn't really help me at all because I know what the pitch is. So if I want to get the pitch out of percentage, I would use this formula, but then this formula needs to be switched around so I can actually get the percentage based on the pitch. And then I could take that percentage and I can plug it into the first one. And this, the reason I'm telling this incredibly long, boring story to a very quiet computer is that this is the very first piece of software I ever wrote. I had written weird like calculators and spreadsheets to deal with drop frame time code versus non-drop frame time code. I'm not even going to go into that. It's a disaster, and I'm so glad it doesn't exist anymore because we no longer deal with that. But I used a program called Real Basic, which in 1999 that came out with version 2, and it had a UI builder, and it was basically programming in, not basically, it was programming in BASIC, and it could build cross-platform apps. So I built an app and it did nothing but let you say how many semitones you wanted to go up or down, and it would spit out this ridiculous, like 6-digit number that you would then hold down several keys on the tape machine to make that number appear, and then it would show up. And so that was used extensively on that Chili Peppers record, to the point where I actually got a call from Ryan, who's one of the other engineers on that record, asking if I still had it about 5 years later, because he was working on a Studer tape machine, and there's no other way to do it. Okay, people got better at interfacing. This is when I believe basically what the idea was is they assumed there would always be a technician to set stuff up, and then there'd be idiots like me running the stuff and just pushing the buttons that were available. So I could push play and record, someone else would come in and change the speed of the tape machine. But obviously, in a creative session, that's not the way it works. Things got better on the hardware side, but I mean, even drum machines, the Lin drum machine, when you set the swing, you had to go into a little sub menu again on LED display, not LED, the little 8-character displays. And you chose from A through F, and those were the swings you had available to you for a drum machine. But let's go to digital land. So if you remember back to the first slide where I showed lots of analog gear, let me go back to it. There are very few controls, because those controls are controlling the things that will change the sound, and they're changing stuff in the circuit. So then you get into digital land and you can do whatever you want. You can make the UI as exciting, as simple, as complicated as you want, and instead every single person in the world did an 1176. I'd like to say that we have enough 1176 plugins now. Now, if any of you are working on an 1176 plugin, then I would say that we only have enough minus however many you're working on. But when you're done with that one, maybe don't start another. This is not all of them. This is just, I love this screenshot because it's from an article where somebody actually compared all of them on drums and bass. I don't know who won. And also, I want to thank Anurag Chaud for bringing up the phrase skeuomorphism, which is exactly what this is. This is bringing something from the analog tactile world into the digital world as a UI, because people are used to it, or because maybe you can't come up with another way to represent things that makes sense. So you have this sort of interface design, which there's nothing wrong with it, because there was nothing wrong with the analog interface. The interface was very simple, and the only controls that were exposed are the ones that people needed to change. And then every once in a while, there would be something that maybe you might want to change, and they would put an extra knob or a screw on the back of the gear, like an LA2A, which only has 2 knobs on it, and only one of them actually affects the limiting that happens inside the box, has a knob around the back that changes the frequency response of the detector circuit. And that sentence was complicated enough that most people who were using the front of the box didn't even know what that meant really. And so they put it around the back, where you'd have to crawl in the back of the rack and change this. And the idea was you could make a de-esser out of your limiter, which is now worth $8,000. So you could have the most expensive de-esser on the planet if you went around the rack with a screwdriver and turned this knob up so it only looked at high frequencies. Then obviously, as digital processing got more complicated, because you could do so much more in a box, and then processors got more powerful, so you could do so much more in an individual plugin in real time, the interfaces got more and more complicated. And then there was this sort of backlash to the one knob interface, or in the case of that really great plugin on the bottom right, 4 knobs. And this is another great UI design, I think, where you completely hide the complexity and you say to the user, this plugin kind of does this. And if you turn the knob, you get more of it. And if you have too much of it, you turn that down. And then maybe you've got 1 or 2 other controls that are ancillary to your main control, but that's it. Now, that control could be controlling one parameter of the equivalent of a gigantic circuit, or it could be controlling lots of them. And the reason I put one of my plugins here is because this on the bottom right, it's parallel particles, which I developed with Waves. And the idea was that I use a pretty complicated template for my mixing, which involves lots and lots of parallel compression and other parallel processing, reverbs and delays, but also less traditional parallel stuff like compression and frequency modulation, but also the words are flying out of my head. I use a lot of parallel stuff. And sometimes some parallel stuff feeds other parallel stuff. So you could have pre and post parallel stuff. And they had wanted to come up with a way to let Waves plugins users have that sort of setup, but in a way that wasn't going to be a nightmare. You didn't have to use 5 auxes to get the audio routing necessary to do the sort of things I was doing. And we were looking at interplugin communication and all kinds of stuff to try and build this so it would actually be what I did. And we realized after a little bit of time, and we did spend some time on it, that there were 2 problems. One was at that point, you really couldn't send anything other than metadata between plugins. It was really difficult to send actual audio. This plugin's old. It's kind of crazy to me, but I think it's coming up on 15 years old, which that's not really possible because I'm only 15 years old. So what we came up with instead was, all right, how do we build this into one plugin? And I said, well, how about we just go the opposite way and make it unbelievably simple and don't let anybody know what's going on under the hood because it doesn't matter. There's no reason to know what's going on if it would be too complicated for you to set up yourself. So the idea was there are 4 parallel processes here. There are 2 that are sort of frequency generators. There's an air, which is, if you're familiar with the Aphex or oral exciters, it's that same kind of idea where rather than being an EQ to add high frequencies to a sound, it will synthesize high frequencies based on the upper mid-range frequencies. And this is really good for brightening things up. Let's say you've got a vocal recording where there's a lot of hiss or there's just noise that's in those upper frequencies. So you can't just crank the high frequency shelf and have a nice bright vocal. But you could create some higher frequencies based on the mid range, and you would get the feel of a brighter vocal, but without having to turn up the problems. And then sub is the same kind of thing, but rather than actually adding subharmonics, it adds the harmonics of these subharmonics. So it's more of a psychoacoustic process to make it sound and feel as though there is another octave below what you've got going on, but you haven't actually added a ton of stuff down at 20 or 30 hertz. And you start to trigger all your limiters. And then all of a sudden, you've got a mix that sounds really good until you actually try to listen to it. So that's the idea with those 2. And then on the left and right, you've got something called thick and something called bite. They're basically parallel compression chains, and they're just different, and they do different stuff, and I had to come up with a name for them. So I called them thick and bite. And the idea is that as you turn the knobs up, you get more of them. So it looks like it's a very simple mixer, but what's going on behind the scenes is with the compression ones, at different points on the knob, you are turning up the input or the output or both, and actually changing compression ratios and also changing release times. And with the harmonic generation, you're changing not only the amount of the new harmonics, but you're also changing balance and EQ on the main signal, because as you really start cranking, I didn't want it just to get louder, because if it's only a lot louder, nothing sounds better than level, and people get tricked. And I thought, this is great. This will be 4 knobs. They all sound totally different. Oh, and there's also a lot of cross routing between the 4 of them. So the outputs of the 2 parallel compression circuits get summed in a way, but it's not as simple as just mixing them together. And then they go off to the harmonic generation stuff, and then it all meets up at the end. What I wanted this to be was I got something, it sounds good, I think. It needs something, but I don't know what. So turn one of these knobs. And if it's worse, turn it back down and turn a different one. And if some combination of these 4 knobs is not the thing you're looking for, well, hopefully, because it's doing so much stuff all at once, you would hear it kind of get close to what you wanted, and then you could go back to plugins that you know well, but have more, not necessarily complicated, but more complete interfaces where you could tweak and have a lot more control. The feedback on this was that everybody wanted to know what was going on under the hood and why weren't there gain reduction meters and what frequency were things at, even though there is a frequency for the little sub guy. And I think, there's some people who like it, but it was not as big a hit. And it was really interesting to see this almost backlash to the very simplified UIs. And to me, it was sort of, what do you think? I'm stupid? Like, I know how to run gear. Give me all the knobs and I'll run the gear. And of course, what that leads to is what's going on behind me, which is my favorite thing in the world, which is modular synthesizers, where everything is exposed if you have an analog module. Absolutely everything is exposed. And not only are all of the controls exposed, but everything in the signal path is exposed. And controls for everything that controls the signal path are exposed. And the complexity that you can build so quickly with this is, I think, that there's a reason people like it is it's because you have very, very small modules that are generally, and we're going to talk about this in a second because it's not true at all anymore. But when it was analog modular only, the modules themselves were not very complicated. So they might have 15 knobs on them, but those knobs all made sense because that module did a thing. And the thing was not necessarily completely easy to understand, especially if you're using a buchla or something like that. But you knew what an oscillator was. You knew what an envelope was. And these are building blocks, but you can control them. Now, I mean, you look at some of the modules coming out, and it's insane what they can do. And that's because we've gotten to the point, sorry, where you have digitally controlled analog modules and then a lot of pure digital modules. And they're awesome. And I use them all the time. But you have gotten back to the point of having to remember to hold down these two buttons while you turn this knob because that puts it into the other mode, where then when you hit the other button with your nose, you can make it do the thing that you can't do until you put it in that mode. But now all of the basic controls are gone because you got it in the other mode. It's awesome, but it's also interesting how we've cycled right back around in one of the parts of music creation that used to be almost in some ways you could say the most pure. There wasn't some circuit behind hiding behind the front panel with some knobs in front so you get to control a little bit of it. You got to control everything. You can still control everything, but if you had like the modular, oh, you can't see behind me because I got a slide behind me. There's a big modular behind me. It's big. If it exposed every single control on all of the modules, it would be the size of my house, and my house is kind of embarrassingly large. So that would be insane, and you can't do it. So then you come back to this idea of how do I compress the UI so that people get exactly what they need, both in terms of control, but also in terms of feedback, but they can work quickly and it can be recognizable. So here are two examples of plugins that do that incredibly well. In the background is the FabFilter Pro Q3, which has no UI when you open it up. It's just a picture of the audio you're playing. And then you create the UI as you use the plugin. I want another band of EQ. I want another band of EQ. I want another band of EQ. And so the UI gets more complicated the more you use it or the more you try to do with it. But at the same time, they still hide everything because every band of EQ is just a dot, colored dot. Hover over it, you can see some controls, but it's a dot. And you use modifiers and drag the mouse around, and you can change most of the parameters you would need. It's really incredible, and, they're not the only ones to do it. It's the first one that I saw that did it, to have a completely blank UI that was infinitely customizable, but also incredibly easy to understand what's going on. Just really, really smart. Then in front of that is one of the best plugins ever designed. I would say that, you could teach a course in this plugin. All right, I'm kidding. It's because it's mine. This is a channel strip that I helped develop for Waves, and just we developed this. I think this is over 10 years old now. Again, scary to me, but I use this all day, every day. So this was the don't try and recreate what you do for other people. This is a what do you want plugin. And for me, I had lots of plugins that I used a lot. There were probably 4 or 5 plugins that I would use all the time. Some for saturation, some for compression, some for EQ, and then a couple of special ones. And so I wanted them all in one window because I hated doing the same sort of thing on 20 tracks in a session. And instead of opening up 20 plugins, I would be opening up 60 or 70 plugins to get to all of the stuff that I wanted to do. And those things all interact. So when we designed this, one of the things I wanted was for it to be very, very flexible. So you can reorder the modules, but the modules don't change their look, but it's got a huge number of knobs on the front, and it can look really confusing and scary the first time you look at it, especially for people who aren't really that experienced with more complicated music workflows. They've been using stock plugins so far, some of which can be quite complicated. But the idea of a channel strip in a window this small, that's a hell of a lot of stuff you've got to control. So, what our idea was, first of all, we were going to hide half the controls. So, I should have had an open instance of this because then I could actually show you things, but you can get a demo. So, if you see in the upper right, just underneath that white strip at the top of the UI, there's a little kind of zoom window zoom box, 2 rectangles. I'm sure there's a name for that, and you know what that name is. And what that will do is that will open up expanded controls for each of the modules. So the very first thing we did was just hide them. And then the next thing we did was we've got lots of smaller knobs. Those are all going to look exactly the same because they're smaller, so it won't be confusing, and they're too small to get any kind of recognizable visual feedback on quickly. But the large knobs are going to be different on the different modules so that it's easy to find things. And so we did stuff like with the larger knobs, you've got 3 modules that have them Bakelite, but the compressor module, which is all the way on the right, has the 3 main controls for the compressor itself on that silver background. So that's the compressor, really easy to find. EQ, it's all small knobs and there are tons of them, really easy to find. The de-esser is the only thing that has 2 of everything, and we gave that these silver collars because that's kind of a special module, and it's not necessarily one that you would expect to have in a channel strip, and so you've got that. Then the gate, I didn't even want the gate. They said we had to put a gate in, so I don't really care about that one. And then that's not true. It does some really cool stuff. And then the preamp was built over the filters. So we thought, well, that's going to help differentiate it. And especially because you can reorder them, that became a huge consideration. We had finished the audio for this plugin, I think 3 or 4 months before we finished the UI. And we were right down to the last day before it got released. And we were still tweaking things because it needed to be this thing like where you turn away and then you come back. And like, okay, the compressor is module number 3. And you had to be able to do that 10 times in a row, or we hadn't gotten the UI right. So I love the fact that you can have this sort of challenge to have no UI at all, or to have a huge amount of UI, but both of them need to be intuitive and usable. But I would certainly take the fact that mine is skeuomorphism all over. It's analog gear because it's an easy way to represent stuff. And there was a great presentation about designing a new DAW that started off with a quote that you shouldn't design a new DAW. But touching on, and that's of course where the skeuomorphism came into the day. It's this idea that the workflow hasn't changed a whole lot, but the tools have. But because the workflow is kind of the same when you're recording music, that maybe the interface to recording should sort of be the same. And that's the way Pro Tools works. And I use Pro Tools all day, every day. It makes perfect sense to me because I know all about tape machines and I know all about mixing consoles. And you kind of get those two. And then it just does a million things on top of that. But there was this sort of revolution when Ableton Live came out because it was the first thing that took the drum machine model and applied it to music. Now, there were lots of ways you could put loops in an MPC 60 and all kinds of stuff like that. Like, this wasn't a brand new model, but it was a brand new application. I'd have to say that when it first came out, and the arrange window, like, as far as anybody knew, that didn't even exist. Like, this was it. This was the window. And there were so many people I knew who had done a lot of work with MPC 60s and things like that who just lost their minds because for them, this was a skeuomorphism of what they had wanted to work on for music all the time. Whereas nobody else had done this. Everybody had used that for drum machines and possibly sequencers, but that was it. So now all of a sudden you've got a new interface for creating music. And there have been a million of them since, and there's probably lots of them before. I put this together recently, and it's not like I've researched every DAW, but I do think that this was really a sea change, not only just in DAWs, because it changed the way you think about stuff, but it really started to open the door for people to think differently. I had a program called Sony Vegas, which only ran on Windows, which could time stretch loops as well as Ableton could. And it's got to be at least 5 or 6 years before Live came out, but the interface was terrible. It wasn't like this. It didn't feel great. You just kinda you could make loops different tempos, and that was cool. Whereas this made it music creation. You're gonna make a record in this thing. You're not just gonna make a track that then you'll finish somewhere else. And then obviously, well, not obviously, but to me, what this did was then spawn a huge generation of hardware controllers where you could go back to this idea of just grids of buttons like drum machines, like the MPC 60, but have them be more like soft keys because now you could light them up different colors. So you could have this sort of recognizability of function, but on a huge grid of buttons. So you could have way more buttons than you could on a drum machine where you have to label them kick, snare, or an MPC 60 where you could have 20 or 25. It just made things easier to make complicated in terms of the number of controls, but simple in terms of looking at a piece of gear and getting on with it. Now, there's still UIs being made. These are just three examples of things that are not the same as every other UI, those sort of based on it. The one on the left is called GeoShred, and it is a different way of inputting music. It uses a lot of the stuff that's built into MIDI 2.0. It uses MPE, but it also has this like smartly quantized pitch performance type thing. I watched the videos. I have not actually used it. It looks really cool. It is a different way to interface with things. And strangely, or not strangely, but interestingly, most of the sounds available for it are acoustic instruments. So it's meant to be a new way to perform traditional instruments, not a way to make new sounds so much. I mean, obviously, there's synth stuff you can do as well. On the bottom right is the Roly C board, which basically takes the traditional keyboard because there's nothing wrong with using keyboards to input music. It's the way, certainly in the West with the 12-tone scale, it's something that makes sense. But it adds this sort of fluidity for moving between notes. And then also it supports all of the new type of performance features that you can have given new MIDI and the way the synths are implementing it. And then up at the top, it's a little nod to the wind controllers, which started in the 80s. And the Iwi was one that used a couple of times. Yamaha made this wind controller thing, and it worked. It was just covered in spit all the time, though. It wasn't the nicest thing in the world. But they also made a breath controller, which could give you some very sort of human input. And I think what the point of all of these interfaces is to give you more than just off on velocity kind of control over what you're doing and just try and make things much more expressive. So now we'll talk about a little AI thing. So let's go back to our user purpose context Venn diagram because I managed to make circles that have stuff. Um, well, what's the deal? Were you almost done? Good God. I've been talking a lot more than I thought I would. So just really, really, really quickly, the AI tools that exist right now are unbelievably cool. Here are three of them. Now let's talk about them individually. because all of these are using AI under the hood, but they present themselves in very, very different ways. So, Isotope Neutron, it uses AI to figure out what settings to put on very traditional audio processors. So you get an interface that looks like any other plugin. I mean, this has the look of the Pro Q3. That's a very common thing now to show each EQ band as a dot on an EQ transfer function. And then you've got different modules that will all look sort of traditional. And then you've just got a button up top that says track assistance. So the AI is like, hey, let me take over, just hit a button. I'll listen, I'll tell you what to do. But then you can come back and in a very traditional way tweak all the stuff that it did. Then you got something like spectral layers from Steinberg, which is amazing. I use it all the time. This is meant to be a tweak fest. And it is a tweak fest. And interestingly, all of the tweaky tools are on display, and all of the serious trained AI stuff is hidden in menus. All of the unmixing algorithm stuff, it's like you got to go up to a menu and click it, and then you get a little dialogue, and then you hit OK. And then it does stuff that is absolutely mind blowing. And then there's SynPlant, which is a great, cool synth from Sonic Charge, where it will generate stuff based on seeds. It grows things based on your seeds. And the really cool thing is the seed can be a sample that you put into it. And then you get into these really weird UIs. But you're doing something weird, and the UIs are actually unbelievably intuitive. I'd say if you don't know this plugin, definitely check it out. The use of UI in this plugin is extraordinary. It's really, really good. And then I wanted to, what's the deal? We got 3 minutes. Is that the deal? I don't remember if I'm supposed to go 40 or 50 minutes. What I'd like to do also, I know we've got a break coming up after me, but I'd like to go to the GatherTown main auditorium thing, which is where most of you are probably sitting. Because apparently, if I go on the stage, I can stand there and then people can come up and actually ask questions. Because doing talks without feedback and Q&A is so weird to me. And it's why I'm babbling, and it's why I'm probably going over time. I just have a couple more things I want to mention. So the AI training models and having either 100,000 songs or, I mean, how you decide to train something to deal with audio. There are lots of different ways you can do it. You can use existing libraries, you can make your own, or you can use targeted ones. There was a great presentation at ADC a couple of years ago about the guy who had done the program that would spit out Drake rapping about whatever you wanted. And that's awesome. It's also, if you tried to charge money for it, you'd go to jail, but that's okay. But I wanted to just talk really briefly about what Peter Jackson's crew put together for Get Back, and then also now they've been using it on a lot of the early Beatles remix records, where it's a targeted set, much like, okay, we're going to listen to Drake songs and we'll figure out how to do his voice, but it's even more specific than that. It's here's a song that has all the instruments mixed together. I want to get the bass by itself. Here are 5 other performances by the same person of the exact same bass part. And I feel like this is something, obviously, their compute power is gigantic compared to everyone else on the planet. But this kind of thing in the hands of people who make records would be such a boon. It would be amazing to be able to extract stuff based on the melody and the performance and the tone of the actual instrument instead of hoping that something like Spectral Layers model is actually something close to what you do in terms of the tones of your instruments, because when it gets it right, it's unbelievable. And when it gets it wrong, it's hard to even do it manually using the other tools. Moving on very quickly, I don't know if any of you saw that this was announced. It's got to be almost a month ago now. Spike AI, Spike Stent, one of the best mixers in the history of mixing, unbelievably nice guy. He's done a million records. And so he, along with his son, apparently, have developed a mixing system that uses something to do with Spike, whether it's his mixes or stuff he likes, or he's trained the model himself. I have absolutely no idea. I don't even know if there's a proof of concept build of it yet, but it seems to be further along than just a website. So this was the holy grail for a lot of software companies for a long time, is how can we mix? How can we make that happen? And I'm saying don't, please, because I like to eat and it's the only way I can make money, really. And then the last thing I want to end up on, and this is what I'd like some feedback on. This is Sequencer plugins. And you might notice that they're all really, really, really complicated, except for the one on the top left. And that's because I wrote it, but I wrote it in SoundFlow and it's only in JavaScript. And I'd like someone to help me move it over to C++ and Juice so I could have a MIDI plugin. Um, that's it. I think we got to stop. So I'm going to go to Gathertown and hang out on the stage. And I know that everyone else is probably going to go eat. But if you had questions, please come and ask. And then I won't feel like I was talking to an empty room for a really long time. Um, Thanks.